Welcome back everyone. So in this video of concurrent assertion, we are going to talk about a very powerful operator, two very powerful operators to be precise. And those two are goto repetition the goto repetition, which is denoted by something like this, and the other one is uh, non-consecutive repetition, which is denoted by equals to inside square brackets. So let's begin with our go-to repetition, and let's try to understand how convenient does this make our sequence to be when we use go-to repetition. I will also write the sequence without go-to repetition to help you understand that how much of a hassle it will become if you don't use this. So let's begin. So as always, my approach is going to be very practical, and I will begin with an example. So our first example, which is for go-to repetition, let's remove. So our first example says that if A is true, then B can be true. Then B can be true on any of the following clock cycles. But it should be true for at least twice or at most 10 times. And right after that, see, when this particular pattern is passed, that B should be true at least for 2 times or 10 times. So note one more thing, that these particular repetitions of B, repetition reps, are not required to be consecutive. So these reps are not required to be consecutive. So which basically means, let me demonstrate this. So if A is true, then on any of the clock cycle, either one of on the next clock cycle or the second clock cycle, B could be true. Then when it follows the pattern that B should be true for at least 2 times or at most 10 times, then the particular assertions or the pattern should not be consecutive, which basically means that B could be on the next clock cycle, which satisfies the at least the minima condition that it should be true for at least 2 times, or it could be true in that 10th clock cycle. It does not matter. So the threads will keep getting generated and it will keep detecting for the patterns. So this is the pattern. So after that, C should be true. So when the pattern or the condition of B is detected is true, then C should be true right on the next clock cycle. So how could you do that? So first I will just write the sequence, and first I will write the sequence, and I will help you understand that how complicated it become if you try to write it without the usage of the go to repetition operator. So let's begin. So I will name this sequence as sequence, and n indicates not go to. So I will just write not go to, and I will begin with my sequence. So our first line says that A is true. If A is true, then on the next clock tick, then B can be true on any of the following clock cycles, but it should be true for at least twice or at most 10 times. But the repetitions are not consecutive, so it can appear in any of the following clock cycles for this numbers of time. So how could we solve that? Let's begin. So we need to use a bracket, and then we will write first thing, and that thing is B is not true, and I will help you understand why. And B can't be true. It can't be true either for 0 times or either for infinite number of times. So using this, it will satisfy the condition that the reps or the repetitions are not required to be consecutive. So B could be true, B could be false, um, either for 0 times or uh, either for maximum number of times. It does not matter. But when this happens, then B should be true. I know it is getting really confusing, but don't worry, you will understand it. So I will tell you why I forgot a bracket right here. So try to understand this. So this is a condition for a single B being true. So B could appear right after A, and it could also appear 2 or 3 clock cycles after A. So to satisfy that condition, we are writing this, that B could be true. Sorry, B could be false either for 0 times or either for multiple times, and then B could be true. And this total pattern is required to be repeated for at least twice or maximum 10 times, which is written right here in our condition. And then right on the next clock cycle, C is required to be true. So this satisfies this condition. So if you try to imagine this, let's say A is getting asserted in the 0th clock cycle. Uh, just make it even more simple. The first, third clock cycle, fourth cycle, sixth cycle. So let's say A is getting true the 0th clock cycle, or whenever the A becomes true, you start counting the clock cycles. Then this condition ensures that B could be true at any of the following clock cycles. So B could be true right on the next clock cycle. It is because we have mentioned that B cannot be true. Suppose B here is true, and we have mentioned that B cannot be true for at least uh, remember this is a consecutive repetition. So for at least 0 times, which also satisfies this that B is not true for 0 times, and right after that B is required to be true. So B is not true for 0 times and B is true. So this satisfies this condition, and this tells us the how many times this pattern could be repeated. So let's say B is true. So one repetition is rejected, and as per our requirement, it should be true for at least twice and at most 10 times. So let's say on the next clock cycle, B is not true. So does this still satisfies this condition? Yes, because B is not true and it could remain not true for infinite time as per this condition. So let's say on the next clock cycle also, B is not true. Then on the fourth clock cycle, B is true. So this also satisfies our condition, and uh, this whole values or patterns of B not true, then B is true, only concludes only one repetition of this entire sequence, because here it says that it will keep looking for the sequence, and the threads will keep getting generated until it detects a B true. After B is not true, even for infinite number of times. So it will keep detecting. Thread will keep getting generated. So when B is true, this concludes one more sequence or one more repetition, the range consecutive repetition. So this already satisfies our condition. So you could have uh, way more B. I mean, it says that at least 2 times and at most 10 times. So B could be true, or the same pattern could be repeated, let's say, for more number of times. Let's say B is not true again. Then on the same 7th clock cycle also B is not true. Then on the 8th clock cycle, B is true. Then again we detected another pattern for this particular sequence. So what this says, here you can see that if the condition satisfied, then C should be true right on the next clock cycle, which means that after we detected the last B, then the C is required to be true on the next clock cycle. So as per our condition, the C should be true right after the last B, the true B is rejected. And remember, the number of true B's should not be more than 10 and less than 2. So this is also you have to remember. I know it is getting quite complicated, but with goto repetition, it is just a simple and small sequence. So if that's the case, that after last B is rejected and then on right on the next clock cycle, at the next clock cycle C is true, then the assertion pass or the sequence pass. Otherwise, let's say then right the ninth clock cycle, C is not true and we detected another B is equals to false. Then on the 10th clock cycle, we detect C is true. Then this assertion does not pass. It does not pass, fails. Because as per our assertion, it is a requirement that after the last B is detected, and right on the next clock cycle, we should detect a true C. So let's just assume that this will get passed. So this is how the complicated the sequence you have to think about, you have to write when you get this type of question or this type of requirement for your test bench. But what if I tell you that using a simple go-to repetition, you do it uh, with few words, and it will significantly minimize the sequence. So let's write another sequence, and this time let's write with goto repetition. And yeah, after sequence, I will put underscore s. So during the debugging time, it will be very easy. You just have to write underscore s and you have to search the code and you could debug any of the sequence you want. Or you can do the same thing for the properties and the other. So right after that, I will end the sequence and here's the simple trick. I will write the same thing when A is detected to be true, then for any of the clock cycles, B is required to be true for at least times and at most 10 times, and the repetitions are not required to be consecutive. But right after the last B is detected, then on the next clock cycle, C should be true. So to write that using repetition, you just have to write B and inside the square bracket, you just have to write the symbol of the repetition and then the range. The range is at least 2 times and at most 10 times. If you look at the question, then it's simple 10. Then right on the next clock cycle, C is true. This concludes our pattern. You see how much simple it makes the pattern. So before that, you have to write this entire thing and you have to think about it before writing it. You have to think about this particular pattern. You have to decide it. And also, there should be another bracket right here. That's it. So after this, you can just write such a complicated pattern using the good repetition and a small range. So let's begin our property, and we want this sequence to be tempered at the positive clock. Positive clock. Then the sequence. Finally, let's assert this property using the concurrent assertion statement, and let's write a label. Okay, that property, and if the property fails, else assertion fails. So this was an example for a go-to repetition which simplifies such kind of complicated pattern into this. Thank you so much. And the next video is going to be on non-consecutive repetition. Thank you.